kind of messy looking. All right, now finding the slope of AB. You could just, bless you. You could just count rise over run, right? Rise over run, down 10 over 25, over 24. Rise over run. That does reduce. That reduces to negative 5 over 12. You remember rise over run? Okay, but the other thing you should also keep in mind today for slope is the change in y coordinates over the change in x coordinates. So all of these things are coming back to visit you today. Are you excited? Okay, so let's talk about this. It's all about the mid-segment. I'm trying to get a better picture here. I feel like it's blurry or it's dark or something. I don't know. The mid-segment of a triangle is a segment that connects the midpoints of two sides of a triangle, and every triangle has 3 midpoints. So let's draw a picture here. Let's just count over, let's say 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It doesn't have to be exact. And then I'm just going to go over kind of 1, 2, 3, 4, 5, and up maybe here. And make a triangle. Now, it says here the mid-segment of a triangle, a segment that connects the midpoints of two sides of a triangle. And every triangle has 3 midpoints. So I'm just going to pretend that I calculated the midpoints and they're exactly right there, and I'm going to connect them. That is called the mid-segment. It's connected by 2 midpoints. Okay, that's connected by 2 midpoints. Now, every triangle has 3 midpoints. There's one here, and one here, right? So it would also have 3 mid-segments if you want to look at it like that. We're just going to look at this one. So that's a mid-segment. There's a theorem based on that. It says the segment connecting the midpoints of 2 sides of a triangle is parallel to the third side. So I'm going to draw my little parallel things. The mid-segment is always parallel to the third side, and is half as long as that side. So if we counted this out to be 14, how long is that? 7. Yeah, okay. So these are all things we got to keep in mind. Okay. I really like using highlighters. If you need to use one, you know, on the test or quiz, I have no problem with that. That's fine. For me, it's kind of hard to see. Some people can see these things no problem. In the diagram of an A-frame house, DG and DH are mid-segments of triangle ABF. Okay, so first what I'm going to do is I'm just going to highlight triangle ABF so I know where I'm working here. There's triangle ABF. Okay, then it told me that DG, which is right here, and DH are both mid-segments of ABF. I need to find DG and BF. Obviously, we're going to be using the idea of the mid-segment theorem. So let's see if we can figure out what DG is first. So here's DG. You gotta look at the whole picture and figure out what can help you there to figure out what DG is. What do you think will help you with that? How do you know that? It doesn't say so. What's 12 feet? AF, and this is the mid-segment, right? And it's parallel to the third side, and it's also going to be half of the third side, right? According to the mid-segment theorem. So DG is half of segment AF, which is 12 feet long. So DG is equal to 6 feet. So again, look at the whole picture. All right, now we got to find BF. What is that, Eve? How do you know that?
Because DH is 10 feet and it's half of BF.
Correct. Okay, this is the mid-segment of this triangle, so it's parallel to this, and it's also half of the third side. Okay, so BF is twice as long as DH, so BF is equal to 20 feet. I really should put lines over there. Not too bad so far, right? Mid-segment theorem. Okay. What can I say about this right here, WS?
It's
The what's it called?
It's mid-segment.
It's the mid-segment by definition of midpoint, right, in a triangle. And if that's the mid-segment, then can I say that these are parallel based on the what? Theorem. Got it? So I need to go through and I need to state the fact that these are congruent. Therefore, S and W are the midpoints of those two sides of that triangle. Okay, so let's just do that. Given RS is congruent to TS and RW is congruent to VW. Then S is the midpoint, I'm abbreviating midpoint, of RT, and W is the midpoint of RV, just based on the definition of midpoint, right? Okay, I'm just going to write that, by definition of midpoint. Okay, so if that's true, then I could say that WS is the mid-segment, or is, let's say, a mid-segment of triangle RTV. All right, so once I've proven that that's the mid-segment of RTV, then I can say that the lines are parallel based on the mid-segment theorem. Cool? Okay, let's finish it then. So, wait, I have to put a reason. Oh, I'll get to the reason in the second statement here. So we can say that WS is parallel to VT all, meaning both of these things, by the mid-segment theorem. Sort of. It's a little bit shaky, but we'll go with it. I can't really say that this is a mid-segment by mid-segment theorem, but forgive me. You get the idea. I should probably say by definition of mid-segment here, and then that. But it's okay. What do you think of that? Okay? All right, then what I'm going to do, we just don't have actual numbers. We're writing with coordinates. We're going to write a proof with coordinates, which helps us generalize the proof and doesn't make it specific for different situations. So this one here, it says write a coordinate proof of the mid-segment theorem for the mid-segment parallel to OB, which is right here. We're given that ME is the mid-segment. So just for the heck of it, let's just mark up a little bit of what we know here. We know that's the mid-segment. And maybe that, I don't know if that'll help us or not, but we'll put that on there because that's what they gave us. So, we have to prove that FE, which is right here, is parallel to OB. We could do that with slope, which we probably will, okay? We also have to prove that this is half of OB. So notice here that we have coordinates. Okay, here at O, what's the coordinates right here? 0, 0, yeah? Here we have, this is B right here, and the coordinates are 2Q, comma 2R. And the coordinates for C are 2P, comma 0. I'm thinking we're going to need to get the coordinates for E and F. So over here, I'm just going to show you how to do it, since it's the first time. Other than this, you probably could just do it right in your head. But we're going to get the coordinates of E and F, because we're going to need those. Coordinates of E. So this one right here, this is E. It is the midpoint, correct? So we're going to use the midpoint formula, which says that we add the x's and cut them in half. So I have 2q plus 2p, yes? So I'm going to write that down. 2q plus 2p divided by 2. That's my x-coordinate for that. And we're going to simplify that in a second. And then the y-coordinate is just adding the y's, 2r plus 0 divided by 2. That's the midpoint, but we can simplify. Take a look. Every single thing here has a 2 in it, correct? So I could actually divide out a 2. And when I do that, what am I left with? Q plus P. And then here, this is irrelevant. When I simplify, it's just what? R. Okay? So I'm just going to write that right here. Q plus P, comma R. My Q looks like an 8. I apologize, it's not an 8, it's a Q. Okay? All right. Now let's find the coordinates of F. I'm doing the same thing. You may not even need to write this out, but I'm just going to do it because it's the first time you've seen it. So we add the x's. So I'm going to say 2p plus 0 and divide by 2. Add the y's. And then I'm going to simplify. This is 2p, that's irrelevant. And what does that just equal? P. And then this is equal to what? 0. So this is P0. Now, some of you could just say, well, I know from here to here is 2P. The midpoint must have been just P, 1P. See? But it's good to see the midpoint formula used there. So now we know those 2 points. Let's kind of now start our proof. Always with the given. And don't write too big. Given that FE is a mid segment. Okay? Well, then I'm going to say, okay, well then E with these coordinates, Q plus P comma R, and F with these coordinates, P comma 0, are the midpoints. Of BC and OC by definition of mid-segment. See, now I think at this point we could just say, okay, because of that, if it's the mid-segment, we can say those lines are parallel. The book wanted us to more look at the slope. So that's what we're going to do this time. But if we've been given that this is the mid-segment of this triangle, then we could say they're parallel based on the mid-segment theorem, right? That's my idea. But what they want us to do is prove that these slopes are the same and then say that they're parallel. So I'm going to show you how to do that as well, because you'll need that eventually. So I'm going to say the slope of FE How do you find slope? We talked about it on the other side. Do you remember? Change in y over change in x, which is also rise over run. Okay, so I'm going to look here. The slope of FE, I'm going to subtract my y's, r minus 0, and subtract my x's, q plus p minus p. Which actually equals what when you simplify? Just r over q. Okay? So the slope of FE is r over q. Let's calculate the slope of OB. And the slope of OB is equal to, so again, I'm going to subtract my y's, 2r minus 0 and 2q minus 0. Okay, so what does this simplify to? Did you guys figure that out already? Oh, isn't that nifty? What do you notice about their slopes? Which means they are what? Okie dokie. Are the same. So FE is parallel to OB by definition of parallel lines. So you're almost done with this coordinate proof. What's the last thing we need to prove? And so what do you think we might use for that? Distance formula. Distance formula. Justin's like, are you kidding me? It's not that bad, I promise. Watch. We'll just do OB, and we're going to do the distance between OB right here. So this is why I was saying it's good to have the distance formula kind of in your head. What you do is you subtract the x's. So just look, 2q minus 0 is what? 2q, and then you square that. So then you subtract the y's. 2r minus 0 is just what? r, and you square that. Now we're going to simplify this because we can. So what's 2q times 2q? Right on. And what's 2r times 2r? Okay, now look at that. We can simplify that further because they both have a 4 next to them. So if I divide out a 4, that helps me because I can take the square root of 4, can't I? It's a perfect square. So the 2 is going to be outside. I know this is squinched, and I apologize about that. So that's actually the distance between OB simplified as far as we can go. We cannot take the square root of q and the square root of r because of the plus sign in between. If it was multiply, you could, but you can't. You have to leave it like that. Okay? All right, let's do FE. It's easier, I promise. So we got to subtract the x's. So I have q plus p. Take away p, which means I just have what? And then the y's, r minus 0 is just r. Oh. Can I simplify that anymore? Is FE half of OB? See it? Because this is twice that amount. Got it? So we're just going to say, even though there's probably a better way of saying it, FE is half of OB. Was that just tons of fun or what?